Hi, welcome back to our Comp1020 recorded lectures. Please look at the end of a lecture, or look on Canvas for a short Canvas quiz covering the main points of the lecture. And I would encourage you, of course, to listen to this carefully, and then go on to Piazza or use Zoom to talk to a TA about any questions you might have. I'm going to talk first a little bit about some stuff for the assignment, and then I am going to go in a bit of a new direction, and we're going to use a sort of a formal set of code to make nice user interfaces, and it's going to be a fairly involved topic, and we're going to spend several lectures on this. All right, so first let's talk about the assignment. And in the assignment, there's sort of a couple main modifications. One is you're changing the types of creatures that are going to be in the game, the zombies and the plants, using inheritance. And then the main sort of gameplay aspect is that you want to be able to click on the screen and place a plant where you click. But we're not placing it exactly where you click. You want it to be snapped into one of those existing cells. So how can we click anywhere and then snap a plant to the correct location? Basically, there's two parts to it. One is we want to first figure out which row and column was clicked in. And then once we have that, we actually know how to do it. Right now we're placing the plants on the screen randomly using a random row and column. And then we do some math to figure out what X and Y location to put the rectangle at. So if when we click, we can figure out which row and column, which cell we clicked in, and get that number, we can then just use our existing code to actually place the plant. So let's think about this. I'm going to just look at it from a column point of view, and the row, and so going across, the column is basically the same. So to refresh our memory, let me draw a little bit here. So this is essentially how we decided how far over to place a plant given a particular column. So if column is 0 times the cell size, let's say the cell size is 50, then the Y position would be 0. If the column is 1, then 1 times 50 is 50, and it would place it the corner on the edge of that second cell, column 1. Remember that the columns go 0, 1, 2, 3, 4, however many you have, right? But we start at 0. So let's say we click, again, let's say we have cell size 50, so each one of these is 50 across, and we click at 112. So 112 would be roughly, this is 100 over, this is like 112 here, so this is about 112 over where the star is. And, just from inspection, it's pretty easy to see that we are in the third cell, 1, 2, 3, and that happens to be column 2, right? So we count from 0. Now the question is, we can do that, and how would we get the computer to do it? Well, we're basically trying to decide, out of 112, how many chunks of 50 are in there. And you can go from 0 to 50 to use up one chunk, 50 to 100 to use up the next chunk, and then basically the next chunk we run out, but we're in that third chunk of 50, right? When I do that, I'm really asking how many times 50 divides into 112. So I want to take 112 and divide by 50. Now if you do that, you get 2.24. And that's close, but the row and column numbers are always whole numbers. And what we really want is just the 2 part of it out here. So we get different ways to get from that 2.24 to the 2. There's math functions that will, for example, take the floor, which means remove all the decimal portion and just give me the whole number part. But it's sort of easier to use another part of Python. And when I do divide, if I do // instead of a single slash, basically it says do integer division. Make the result be an integer. And an integer doesn't have that fractional part. And in fact, it actually just loses the fractional part. So it's not like it rounds up or rounds down. It just loses the fractional part. So even 2.85 would still be 2 doing integer division. So you should try that out on a few numbers. Open up Python and just type in some stuff and see what happens. But if I do this integer division, I get 2 out. And that is the column number of where I want to be, right? And once I have that, I'm done because I already know how to place it using the column number. So if I don't want to click there, and I'm just moving stuff around. Oh boy. Yeah, I'm trapped. I don't have my little like next thing here. Go, okay. Nope, I don't want to be there either in the notes. Sorry, I shouldn't have clicked on the screen here. Next. Usually just arrows to go to the next slide. Come on, give me a little. I'm just going to break the slide for a second. Okay. I didn't really want to do that, but I did. Okay, so if we use integer division to figure out what column we're in, then we just do this math equation forward once I have the column to get the y position of the rectangle. So our rectangle left is the cell size times the column. And again, that should be the same code you're using right now to place a plant randomly. You pick a random row, random column, calculate how many jumps over you go, and move the rectangle there. In this case, we're clicking at an arbitrary place on the screen. We do a little math by doing integer division of the cell size to figure out which column it is, and then we'll do the same kind of thing for the row. And then we go forwards again and place the rectangle. So in this case, we're taking from this spot here and jumping to snap it to the edge of the cell, which is where the rectangle left should be. If we do the same thing for the rows, we would snap it up here, and our star would be in that corner, and that would place the rectangle there, right? So that is sort of the main tricky part, I'd say, in the assignment. You click on the screen, and you need to snap it into a grid. Okay, so certainly that's worth discussing on Piazza if you have questions, but kind of look at that. You know, this is just a couple, you know, the math isn't anything too tricky, but you have to know why it's happening. And the why is that we're trying to figure out which space we're in, and then go forward from there to actually position it. Oops, keep doing the wrong thing there. Okay, so, and somehow I keep clicking here even though I don't really mean to. It's weird. I'm not sure what I'm doing there. Okay, so check that out. See if you can get code to do that when you get to that part of the assignment, and certainly talk about it if you want. Okay, let's talk about user interfaces now. So I need to shrink down this a little bit, it looks like. Okay, so we're all familiar with using user interfaces. We use them all the time. It's very rare for us to actually do what's called the console application, where just text appears in a window and you type text and then it responds to you. We're just using a mouse or even virtual reality to interact with our computer, and it's nice. It would be nice for us to kind of see how that happens from a programming point of view. So here's a little comic. You know, while you're away, I took the liberty of developing the user interface. Can you review it for me? And of course, it's maybe not the most beautiful user interface in the world. What is it? Hey, what do you mean? It's our CD player. Don't give me that. I'm a user too. So when you're programming, you're always told to program for the user, right? To make it look so the user can use it. But of course, you know a program, all the parts so well, it's sometimes easy to make an interface that sort of works for you but not for other people. And there's some nice principles involved in how to make a reasonable user interface. But certainly, people that are doing a lot of coding sometimes, you know, build user interfaces that have a lot of power, but they don't necessarily show people the right way to use this program. User interface is like a joke. If you have to explain it, it's not that good. I'm a little worried about having to explain this joke here, but basically, you know, again, a user interface should be sort of self-explanatory. It should sort of hint to people how it's used, and not require a big manual to go along with it. If people always blame the user, like, oh, the person shouldn't have clicked there, or they should have made it hit save, but often it really is the user interface's fault, and it's good to take sort of critical feedback and make sure you're incorporating it in your design. Now, one thing that's hard about programming user interfaces is that the structure is totally different. Okay, we're still gonna have classes and we still have methods, but we are used to making a main function somewhere, and you start at main and you see what code is there and you execute it one line at a time. And maybe there is some, possible, like an if statement. You can go, you can branch in two different directions, or maybe there's a loop, but you can kind of tell when things are going to run, right? It might run depending on some condition, but it's basically going to run when the code hits that spot. And again, a big skill we've been working on in our programs is trying to make sure we understand the flow of execution of a program. It starts on the first line, and you follow it, and you track it, and it continues on. And that way you can predict what the program is going to do. And in fact, that's how you debug as well, right? You run it, and you predict what each step is going to provide, and if something varies, you're doing something incorrectly there. So that's sort of hopefully getting pretty well ingrained that these programs all run for certain kinds of reasons. GUI programs are different. Essentially, there's something called, sort of like the Python game loop, or Pygame game loop. There's a little part that, don't do that. There is a part of the program that sits there looping forever, basically waiting for you to do something. When you do something, it generates something called an event. So for example, if you hit a key on the keyboard, it generates a key press event. And we did the events also in Pygame, so we're a little familiar with that. But in Pygame, what we did was we just did an if statement. Hey, if the event was this, do this. If the event was this, do this. And that works, but it's kind of limited. So most graphical user interface programs, GUI programs, have a different structure. When an event happens, it triggers some chunk of code. So you set up a connection between the event and the code, and basically when I do a key press, the key press code runs. When I do a mouse click, the mouse click code runs. And when I do, a mouse move, the mouse move code runs. And in some ways, when you're looking at the program, you see all these sort of disconnected pieces. Here's something for the mouse, here's something for the mouse, here's something for the keyboard, here's something for a window move, here's something for a network connection being made. And you can't really tell how they're connected together. It takes a little more effort to see the connections because they're only connected when the user actually does something. So mouse, something happens during the running program, and that triggers that piece of code. So you have to kind of think a little bit more carefully about how these parts work, and it's a little harder to see the structure of the program just from looking at the code. Now, the question is, how do you actually make some of these interfaces? Typically, you use some kind of toolkit. It would be very difficult for us to make a modern-looking application based on the tools we have right now. Although, as we saw last lecture, we started messing around with Pygame, and like I said, let's go to make a button type thing. And it wasn't a very good button, but you could still click on it and make something happen. And then, eventually someone says, well, that button should flash when you click it. And so you add a little more code to make the code flash. And if you do that for enough stuff, all of a sudden you have a toolkit, right? You have a bunch of code that provides something for buttons and sliders and text windows and scrolling stuff and all that. And then you don't have to do that yourself, thank goodness, right? So there are a bunch of toolkits out there. For Python, the traditional one was something called tkinter. And it's okay, but it kind of makes ugly looking interfaces. It's a sort of outdated feeling, and the style of it was sort of strange. And anyway, I don't think it's a very good toolkit. So another toolkit that's actually very widespread is called Qt, QT. I usually say Qt, so I can't say Qt all the time. Probably if you're interviewing for a job or something that using it, you should try out Qt and see how people react before you give up on it. But I'm going to say Qt just because that's what the letters are. So it was originally built for, amazingly enough, Nokia phones, right? And all the little menu things and the little snake game you could play on there and stuff like that were all written in this toolkit. Now, that also was not much of an interface, right? It was barely sort of like a text interface. It wasn't even like graphical in some sense. So it's sort of amazing to me that out of that very primitive beginning in the, I don't know when it was, like the 90s, I guess, or something, grew this giant ecosystem for application development. It's one of the primary toolkits for C++ user interfaces, but Python also has sort of adopted it, and there is a package called PyQt5 that basically allows our Python code to call the original C++ code. Now, I would say like Java and C# tend to have their own frameworks, their own toolkits for UIs, but in both Python and C++, this is a very popular toolkit, so I think it's a good choice for us to use as we're making our own interfaces. And it has some complexity. It is a big toolkit. In other words, there's a lot of pieces to learn. In fact, you can become a specialist in Qt, and if you look for jobs, there are like Qt developers and stuff, because it's a big enough system that you sort of have to have some expertise in it to do a really good job. But it's not that hard to get the basics, and that's what we're going to try to do here. Okay, so let's basically have to add the PyQt5 package, and let's just kind of make a user interface window. So I'm going to shrink this down and start doing some code. I had it all set up. I guess I got to get some hotkeys where I can like switch back and forth between these different size things easily here. And I need my zoom window. Where's, sorry. It's funny, it normally shows, oh wait. Okay. Zoom down to like 72. I know, it's very exciting watching me struggle to move these windows around. Okay. That's going to be a danger here. Let's scoot it over some more. Okay, so to use a package, you know, it's the kind of thing where you're best off in some ways following along with somebody else. So I'm gonna let you follow along with me. There are also online tutorials that teach you how to use PyQt5. And so the first thing you have to do is import something. We haven't imported exactly in this style before. This is the package, and this is basically a sub package. So you can import parts of PyQt5 and not do all of it all at the same time. And so I'm saying from PyQt5, import everything. Again, should I import everything, or should I bring it into a separate namespace? You know, for now, we'll do this. Now, it's complaining to me that doesn't know about PyQt5. I haven't added it to this project. And in the past, we would go and go to the project interpreter and then search for a package and add it there. And that's a fine way to do it. In fact, I hadn't really noticed this, but if I hover over this before, it says unresolved reference PyQt5. Hey, install package PyQt5. Let's do it. So again, you don't have to do this very often, right? But so down here, kind of cut off, it's saying installing package. And even though it is a really big system, it manages to do it pretty reasonably well here. Taking a little longer this time. We'll see if we get through this. Okay. Somehow when I did it the first time, it only took like 10 or 15 seconds, but now it's installing here a long time. Well, give yourself a minute to install the package, I guess, is the lesson here, right? When you're doing your own installation. Also, just keep in mind, we're not using PyQt5 for the Plants vs. Zombies game, right? This is, we're moving on. We're doing the fake Pygame buttons as described in the last lecture for that, and we'll be making our own application in PyQt5 ourselves. Well, while it installs, I can still type, I guess. So let's do that. So the first thing we're going to do is tell. It's kind of all running slow here a little bit. Tell Qt to make an app, and I'm going to do that with saying app equals. So I have some app object, some app variable. And I'm going to construct a Qt application, and it looks like it has some initial parameters you can set in, but I'm sending in an empty list to say there's no particular customization going on here. Okay, so Q application is a class in PyQt Qt widgets, and I'm telling my code that I want to construct a new Q application using that. It really is still installing. That's very curious. I wonder if I had it partway installed before or something like that. Now I'm going to add a label to, so I'm going to make a label to show on the screen. And it's just going to have some text on it. So make a text label. And I'm just kind of keeping the comments up here so I can kind of keep remembering where we are in our process, and hopefully you can see each step as well. So I'm going to make a label equals a Q label. I'll do single quotes on there. Hello world, as is sort of traditional. We often make a program that starts off by saying hello world to show that we can do something in the program. So again, QLabel is a class in PyQt 5, and I'm constructing this QLabel with some text built in. And presumably I can change that text or do other things in my program. Now I'd like to show you here that every big system has like their own conventions. So the convention here is that most of the objects in Qt start with Q. So there's like a Q string and a Q, there's like a Q int, there's a Q everything. So typically if you're doing something, it's going to start with Q, and that's sort of a good way to get started, help you remind you what's possible. Okay, so it seems to have mostly installed. Okay, package successfully installed. I'm going to get rid of that. I'm going to do that. And notice my angry warnings went away. Yay! We can't run anything yet, so making a label is not enough to basically make it appear on the screen. I have to show it. So we're used to that, again, from like Pygame. You have to build an image on the screen, or and then you have to update the screen to make it all show. So everything you make as a Q object of some type, you're gonna eventually show it. Finally, we're gonna run the Qt event loop. So we're gonna tell Qt to go off and run the GUI that we've set up. So essentially the job for us here is to set up the GUI and then tell it to go. It never really comes back from this. You can't write code after the exec call because it gets sort of stuck in there in this infinite loop, the game loop essentially, right? But then Qt manages these things that we've built. All right, so let's run this. And did it show up somewhere? Okay, yeah. It showed up minimized for some reason. I'm not sure why, but we get something out of this. We have a window that we can drag around. So that's already something that, like on a console, we can't do. We can't place the window. I can actually drag and resize the window, and it actually has some behavior. Notice it tries to keep that thing centered top to bottom, the text in it. There's probably other ways I could do it that would also center it left, right on the screen, or provide padding, or let it wrap, or anything like that. So I can make it, make it real big, and hopefully I can get out of that. Okay. And I can minimize it, and thankfully I can also kill it with the red button there. Okay, so there's our first PY Qt button. All right, so now let's add something else. So, and again, the way you learn all the parts are you either want to do something, you go like Google, like how do I do this, and you see an example, or you're following some tutorial and you pick up some basic skills, and then you start seeing different ways to put those things together. I want to add a button. So I'm going to make a variable button, and I'm going to make a new button object. And if you had to guess, in the Qt system, it is a Q button. And I can provide some text that shows up on the button. And why is it unhappy? Oh, it's not Q button, it's a Q push button. I guessed wrong. And again, you know, you just have to pick up some of the different tools available to you as you write these applications. Now I made a button, and again, that's only half the battle. The other part is you want to show it. So just kind of get into that pattern, right? You make it and show it, make it and show it. If I run it now, hey, so the button appeared. In fact, it acts like a button. It doesn't do anything. I didn't specify the behavior when you push the button yet. That's a whole nother process. But the problem is that I don't see my text anymore. And in fact, when I try to grow this, the button expands along with it, and it's not like I can see that original text label. So I've killed off the hello world text label, which is not a good thing. All right, so the question is, where is it? Oh, well, that's weird. Now I have two windows, one for each thing, and that's not what I want. I want both together, and so we need some mechanism to basically join these together. And if I kill both of them, it stops the program. Okay, so what do we need? Let's go back over here. Okay, so let's get a little terminology in. So the parts of a user interface, we basically have the things you see are widgets. That's an old term. Like people used to tell people that went around and sold a bunch of little tools and stuff, is they just have a bunch of widgets in there, and it's just like means something like a little thing, right? But it's not a new tech term. It's actually a very old term. But so these things we see are called widgets. So some examples of those are a label like we had, a button like we had, maybe a slider, maybe a spin box, a text area, and so on. Then you need to organize those widgets using a layout. And the layout basically says how they're arranged, but not precisely where. And in fact, half the battle in making a good user interface is learning how to use layouts and kind of being clever with them, so it basically goes where you want, but you're not forcing it. You don't just say put a button at position 100, 200, and then the next button at 150, 200. You instead say put these buttons side by side and keep them side by side as long as you can. And maybe if the window shrinks too much, maybe you'll wrap it around or so on. So you basically end up specifying a bunch of behaviors that say sort of how you want them arranged, but not precisely where, and you let the windowing system basically figure out a nice arrangement for them. And in some ways, that's a lot of the skill on this kind of thing. So when you also have to think very hierarchically. In other words, there's layer after layer of these things. So for example, your application may be a blank widget, a big canvas kind of widget that holds things. And then you have a layout on that widget, on that canvas. And then you arrange other things using layouts inside it. And maybe you have another widget for buttons going across, and then another widget with stuff going this way. And you have all this hierarchy of widgets and layouts that sort of specify how it all looks. And we'll get around to seeing some examples of that. We should keep it a little more simple right now. So first we're going to make a window that's a plain widget. And then we're going to attach a horizontal or vertical layout to the window. And then we're going to put buttons into that layout. So we add them in there. And then it's the job of the layout to control how they're shown and how they go. Okay? So let's change our code to take advantage of this idea of layouts. So first, before I make any of these little tiny widgets, I'm going to make a window. And window sounds special to us because we're used to thinking that's like the main thing. But it's really just another kind of widget. And I'm going to make just a plain one. All right, so a Q widget is just a kind of a generic catch-all for just a big space to hold other things. Then I'm going to make a layout. And the layout is going to be a Q, and I have to kind of vertical box. And we'll talk in more detail about these different kinds of layouts. I'm just going to give you an example of one here. A Q vertical box layout. There's like grid layouts. There's all sorts of stuff, but the easy ones are the ones that just go either column, horizontal box layout, or vertical box layout, and it puts them all in order somehow. Okay, so I'm going to make my little widgets I want to show, the text label and the button. And, oh, what's going on? Go away. And I don't want to show them myself, I don't think. Now I'm a little nervous about what I should do here. And instead I'm going to add those widgets to the layout. So I'm going to say layout, add widget, label, layout, add widget, button. And then I'm going to take the window and I'm going to set the layout for the window to be the layout. And then I'm going to show the window. And again, we're not saying show parentheses window, we're saying, hey window, show yourself, right? It's a method. We're saying apply show to yourself. And then I run the event loop. Okay, so I'm going to run it and then we'll talk about it again. I want to make sure it's all doing what it's supposed to be doing here. Okay, so here's my window showed up. These are in a vertical layout. I have these two things here. If I stretch them out, it kind of, you can specify the behavior, but basically this thing seems to be growing. I don't know why the other one's not growing. And then if I go this way, it goes that way. Anyway, there's millions of options, colors, borders, all sorts of stuff. But for now, we just have a layout to get those two things in there. So what did we do? We made the application, and at the end we exec'd the application. So we always have that as sort of our main part of our program. Very commonly, for your application itself, you make some kind of just a plain widget to hold other stuff. Then we made a layout, and to the layout we added two widgets. These did not show themselves. It's the layout's job to show them. In other words, they sort of belong to the layout at this point. Then, the step that I always forget is to then, for the window, say this is the layout that belongs to the window. And it gets all those widgets that are attached to the layout for free, right? So we have window, we have layout, and inside the layout we have the text and the button. And this sort of forms a hierarchy there again. You have a widget, a layout, and then some widgets. You sort of alternate between widget and layout to kind of get those under control. And then we basically showed just the window. And that showed all the stuff I didn't know about as part of that. Okay, and so if we run it again, we get those things. If I wanted another button, layout, add widget, a Q push button, and I don't know, weird button, right? Notice this thing is not, I didn't even make a variable for it. I just constructed it here and passed it into the add widget. And if I run it now, I get the final button, right? So once you sort of get the structure set up, it's actually pretty easy to start adding things and changing them around. It's nice. Let's see, I think that's all I wanted to cover today. We're going to be talking about Qt again next time and do a lab. And this is sort of now opening up finally Python into, I'd say, a more professional development kind of environment, like be able to build applications that look like real applications. So hopefully you will enjoy that transition. Get started on your assignments and make sure you're asking us questions on Piazza and using Zoom during help hours. Look at the help hours schedule that's been changed under course resources and see how to connect to help that way. Thanks, and we'll have discussion tomorrow in class.